Hello everyone. In this video we're going to be solving an exponential, well, kind of exponential equation. We have 2 to the power x plus x equals 11, and we're going to be solving for real x values. If you want to look for complex x values, you also can look for those. Now, I'm going to be presenting sort of like two approaches, even though they're very similar, and I'm going to be showing you some analytical pieces too. Okay. So we have this equation. When you look at an equation like this, I said sort of exponential, partially because we have an exponential piece and a polynomial piece. So this could be considered a non-standard equation as well. So non-standard equations have non-standard solutions because we can't solve them by regular means. So anyways, without further ado, let's get started. We have 2 to the power x plus x equals 11. When you look at an equation like this, obviously, you can guess and check. I know some people are not happy with the guess and check method, but unfortunately, sometimes that's all you can do. And it works nicely because, for example, in this equation, if I replace x with 1, I'm going to be getting 2 plus 1, which is 3. It's not going to work. If I replace x with 2, it's going to give me 4 plus 2, which is 6. It doesn't work either. But guess what? We're getting closer to 11. So that kind of tells us that if you increase the x values, there's a chance that you're going to be able to hit 11. And that actually happens at x equals 3. If x is equal to 3, you get 8 plus 3, which is equal to 11. Bingo! We got a solution. But here's the million-dollar question. Is that the only solution? And we're going to answer that question by looking at it from an analytical perspective. But before, here's what we need to do. I would like to separate the exponential and the polynomial pieces. Okay, here's what I'm going to do. Subtract x from both sides. That's going to give me 2 to the power x equals 11 minus x. Great. Now, why did I do that? By doing this, I'm kind of separating the two different kinds of functions. So that's kind of nice. Also, if you look and focus on the left-hand side, you do get an exponential. And on the right-hand side, you do get a linear function. And what is the critical part here? The left-hand side is increasing because when the base is greater than 1, b to the power x is an increasing function if b is greater than 1. And as you know, it's decreasing if b is between 0 and 1. So in this case, we have an increasing function. So this function is increasing. Let's just use INCR for increasing. And 11 minus x is a line with a negative slope. Therefore, it is a decreasing function. Now, what happens if you have an increasing function and a decreasing function intersecting at a point? That is going to be the only intersection point. So let's go ahead and take a look at the graph of these two functions together. Now you're going to know what I'm talking about. Okay, so here's the graph of y equals 11 minus x, which is the green line, and the graph of y equals 2 to the power x, which is the purple or the violet graph. And as you can see here, they're going to intersect at 3, 8, which tells us that x equals 3 is the only solution to this equation. Well, how do we know that they're going to intersect at one point? Because one of the graphs is always increasing, the other one is always decreasing. If you think about it, they can only intersect, if they do, at one point. Great. So this is basically what it is, but let's go ahead and look at the second approach, sort of. Now you didn't have to separate this. I know some folks already thought about it, but if you consider the function as is, like this, well, what kind of function are we talking about? Well, I'm looking for the intersection point of these two functions. Is the function on the left-hand side an increasing function, a decreasing function, or neither, right? Here's the thing, you can find out by differentiating. Let's go ahead and differentiate this function. We get 2 to the power x multiplied by ln2 plus 1. As you know, 2 to the power x for all x values, it's going to be positive. ln2 is positive because 2 is greater than 1. So adding 1 is going to make it positive as well. So y prime is always positive, which means y is increasing. Great. So now you have an increasing function and you're looking at a horizontal graph or line. How can they intersect? They can only intersect at one point. Why? Because they're going to look like this. You're going to hold. Now, here's the important question. How do you graph this function and what does that look like? So we're going to get into a little bit of limits here if you don't mind. If x approaches positive infinity, now if you look at this function, you're going to notice that this is going to approach infinity. But notice that x is going to be insignificant and our function is going to look like more like exponential as x approaches infinity. What happens if x approaches negative infinity? That's going to be an interesting one to look at as well. Well, if x approaches negative infinity, this guy is going to approach 0. So you're going to end up with an x term. So our function is going to look like, but since x is going to be negative, right? Actually, by the way, it should be y equals 2 to the power x plus s. Okay, great. So I'm not looking at the wrong thing. So as x approaches negative infinity, this is going to approach 0, and our function is going to look more like x. So we kind of have the following picture. Our function is going to look like x for positive x values as x approaches infinity, of course. Otherwise, it's going to look like the y equals 2 to the power x. But obviously, for negative values, it is going to. So in other words, this is what the graph is going to look like pretty much. Sort of like this. Okay, obviously, it's not going to go from 0, 0. It's not going to go through 0, 0. But the idea is if x is 0, y is 1. So you're going to have a graph like this, curvy, like an exponential function. And then it's going to be pretty straightforward after that. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. You're doing a great job. You're awesome. Thank you for all the good wishes. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.